Hi everyone, we're group 2 and today we will be presenting our website VaxTracker. We created VaxTracker as a website that allows users to find data about COVID-19 vaccinations quickly and easily. Our 4 models include global COVID-19 vaccination data, where you can see how various countries around the world are doing at vaccinating their citizens, clinical trials relating to treatments and vaccines for COVID-19 around the world, beliefs surrounding COVID-19 vaccines and COVID-19 in general, and information on COVID-19 vaccines that are currently in use and those that are still in trial. And now for an introduction to the team behind VaxTracker. I'm Lilia, and I was a full stack developer for VaxTracker. In terms of backend, I worked on creating our database using MySQL and SQL Alchemy, designing the database schema, and populating the tables from our various data sources. I also pulled our member statistics from the GitLab API and wrote the Python unit tests. In terms of front end, I created the splash page, made the visualizations, wrote code to fetch our data from our APIs for the front end, as well as refining the overall UI of our website.
Hi, my name is Anjita, and I was also a full stack developer. From a backend perspective, I populated our countries database with data from our APIs as well as our supplemental data sources. From a front end perspective, I refined the About Us page by creating the card and grid structure to organize the tools and data sources that we used. I also created a consistent and modern interface with the grid system to organize the information for each of our models instance pages. And finally, I helped work on creating the media for our model pages.
Hi, my name is Evan, and I was also a full stack developer on VaxTracker with a focus on front-end development. Just to give you a brief overview of some of my responsibilities, I created and updated Postman API specifications with Seth, designed and implemented country model instance pages, implemented searching, sorting, filtering on the front end for UI cards, created unit tests and asynchronous API calls, and I fixed various UI bugs and inconsistencies.
Hi, I'm Seth, and I implemented the RESTful API that Evan and I designed using Flask and SQL Alchemy. I also dealt with all the technical AWS hosting stuff, such as setting up Elastic Beanstalk, CloudFront, Route 53, and S3. Once the API was implemented, I also worked on updating the documentation on Postman to correspond with what was actually created, because the API changed a lot after we specified it.
Hi, I'm Minkang. For the backend, I searched and tested external APIs as our data sources. For the front end, I implemented template React components for our models. I also implemented pagination, model-wise and site-wise search functionalities. I helped create and fine-tune our instance pages and implemented the map component at the media. I also worked on creating just unit tests and creating visualizations.
So now let's take a look at our website. Starting off, we are on our VaxTracker splash page. You're immediately greeted with a welcome to VaxTracker. And if you click on this down arrow, or if you just scroll down, it will lead you to one of these, our 4 cards that display our 4 different models, in which you can click on any one of them to navigate to that specific model's page to learn more.
Now let's go to our About Us page. So first, we have a description of what the website is about, so our users can understand. Next, we have descriptions and GitLab statistics for each of us members who helped create the website. And finally, we have all the tools, data sources, and APIs that we use throughout the course of this project easily displayed for our users.
So the first data model we used for VaxTracker was the country model. The global vaccine data page presents the user with a grid view of different countries. The top of the page has various drop-down boxes that you can use to sort and filter the country cards in different ways. For example, here is an example search for Belgium. And if you click on any country card, it'll bring up a vaccination dashboard for that country that shows the number of vaccinations, active COVID cases, and other things. Below the stats are the map and a flag, and then below those are lists of approved vaccines for the country and clinical trials.
Our next data model is the clinical trial model. Each COVID-19 related clinical trial has an associated database entry, a UI table entry, and a customer model instance page. Each clinical trial instance page contains a dashboard similar to the one used in the country's model. The one of the dashboard shows like a quick useful bits of information like the study type, enrollment size, and age requirements.
On top of that, each clinical trial instance page contains links to each country participating in the trial and to the beliefs for the corresponding countries. We use MUI data table to organize our instances for this model. We also take advantage of its built-in search, filter, and sort functionality. For searching, we implemented customized body renderer to integrate the highlighting functionality for search queries. For filtering, we also write customized filter options to make the instances group in a nicer way.
Now let's look at the COVID-19 belief data. So here is the models page organized. The countries are all organized into a table. Let's click on Australia. And here you can see in one of the instance pages that we've displayed all of Australia's population's beliefs on who would take the vaccine, concern about side effects, worry about the vaccine working or not, trust in the vaccine, as well as effectiveness of masks. We've also displayed the clinical trials in Australia, as well as a button to go to see Australia's COVID-19 statistics. And then you can also see a graph at the bottom that just displays the belief in masks in a visually appealing format. Now let's go over to COVID-19 vaccine information. So here's the main page, again, another table. If you click on the first one, we can see more about Pfizer. We can see all sorts of statistics and information regarding the Pfizer vaccine. And then you can also click on the countries where Pfizer has been approved. And you can also see news articles regarding the Pfizer vaccination.
Now we're going to look at our visualizations. The first visualization we have is for our global data model, where we created a choropleth map that shows the total COVID-19 vaccinations per 100 people for each country. We created this map using an NPM module called React SVG World Map. As you can see, the darker the country is shaded, the more it has vaccinated its citizens, and the converse is true for the lighter shaded countries. If you hover over each of the countries, you will be able to see its exact value as well. Next, we have our beliefs model, which shows the percentage of survey participants who would take a COVID-19 vaccine if it became available to them for each country. We display the data in the form of a bar chart created using D3. As you can see, the x-axis includes the various countries, while the y-axis shows the percentage of survey participants who answered yes to this question. If you hover over each of the individual bars, you'll be able to see the country name and its corresponding percentage. Lastly, we have our vaccines visualization showing the number of COVID-19 vaccines that are in each trial phase using a bubble chart created using D3.
For our providers visualization, we first show a choropleth map for their cities model. We group their cities by countries, get the hotel ratings in each city of each country. Then we show the average hotel rating in each country. In the choropleth map, the darker the color, the higher the average hotel rating for hotels in that country. We can also see the exact rating by hovering over the countries in the map. For our providers attraction model, we group the attractions by the attraction type and create a bar graph showing the number of attractions of each type. The y-axis of the graph shows the number of attractions, while the x-axis shows each attraction category. For their hotels model, we group their hotels by cities and present a bubble graph showing the number of hotels for each city. For the set-wide searching functionality, it is actually very similar to the model-wide search. We first query instances of all our models from our API, then we search specific text in their instances attributes according to the search query. Then we can pass the instances containing the matched text to be the instances to show and use the pagination to determine the instance to show for each page. We also implemented highlighting using React highlight words to highlight the search queries in the attributes. To make a consistent layout, we also created cards to hold the instances of our tables model.
So now that we've taken a look at our website, we can reflect on how we did and how our developer did this semester. So what did we do well? We had different strengths and varying expertise coming into the project, and we did a really good job on depending on each other. We asked for help when needed, and we were very adaptable and flexible as a group. Finally, we did a really good job of delegating tasks and getting the work done in a timely manner. Now, what did we learn? One thing we learned as a team was that assigning work was the most efficient way to get things done. We also learned that regular meetings was very beneficial for us to ensure that everyone was staying on track with their deliverables. What did we teach each other? We taught each other to depend on one another, and that we also learned that knowledge sharing was a very valuable thing throughout the journey of building our website. We had a really good mix of members who were strong in the front end versus the back end, so it was really helpful that we could fill any knowledge gaps along the way.
So what can we do better? We definitely could have planned out our models better, as coming up with attributes, connections, and data sources became a challenge, as we didn't fully anticipate how limited the data on COVID-19 vaccines around the world was. So being more thorough with planning that out would have saved us a lot of time spent constantly refactoring our database. We also could have standardized some UI components for reuse and modularized our code better, as it was difficult to coordinate across multiple front-end developers. Also, we had hoped to implement loading on more pages as well as caching, but we didn't have the chance to do that because of time constrictions. So what effect did the peer reviews have on us? Peer reviews kept us in the know of what our teammates thought were our weak points so that we could improve upon them to boost the productivity of our team. It also let us know what we were doing well so that we could continue doing what worked well and build upon that. What puzzles us? We were puzzled by the lack of consistent data across multiple sources on COVID-19 vaccine information, which caused us some difficulty as we were sometimes working with conflicting information across our multiple data sources, as some of them were likely updated at different points in time. We were also puzzled by various React peculiarities as a result of our inexperience with the language, but luckily we were eventually able to figure these out. And now to our critique of our developer.
So what did they do well? Well, they chose an interesting topic for their website. They implemented a solid many-to-many relationship between their three models that made a lot of sense to follow. The models just fit together in a very natural way. How effective was their API? They used Flask RESTless to implement their API, which has a bit of an user-friendly interface, but it was very functional with built-in pagination. And how well did they respond to our user stories? Well, they did well and were responsive to them all throughout the project. They put comments on the issues whenever they needed more specifics and also included how they addressed the user stories.
So next up is what we learned from them. They did an awesome job implementing the sorting, filtering, and searching across all of the models on their site in a way that felt like really ergonomic and natural. And so we used that as an inspiration for the filtering of some of our components. We also thought overall their UI was very clean and easy to use, and so we tried to use it as an inspiration as much as we could. What can they do better? There were some small UI bugs and inconsistencies across the instance pages. Also, there was some poor use of horizontal space on the instance pages, so it made you have to scroll a lot, which made it hard to read information. The UI cards on the attraction pages could have been made a little bit more attractive by including some form of media on the front of the card itself. And lastly, there was no option to disable pagination on the API to read all of the instances of a given model. And then lastly, what puzzles us about their website, the time zone attribute for each city was stored in an odd format that didn't add much helpful information. We thought another format like UTC or GMT would be more helpful.
That concludes our presentation on VaxTracker. We hope you enjoyed learning more about our website.